From one electron to one consciousness, where physics runs out. There's an old idea in physics that sounds like it belongs in a late-night conversation rather than a serious discussion about the universe. And yet, it was considered carefully by some of the most influential physicists of the last century. What makes it interesting isn't just how strange it is, but where it quietly leads. The idea is known as the One-Electron Universe. It starts with a fact that's easy to overlook, because we've known it for so long. Every electron ever observed is perfectly identical to every other one. Not approximately the same, not indistinguishable because our instruments are limited, but identical in every measurable way. No experiment has ever found an exception. John Archibald Wheeler and Richard Feynman looked at that and asked a question that feels almost uncomfortable in its simplicity. What if this sameness isn't coincidence at all? What if there is only one electron in the entire universe, and what we call many electrons are really the same particle, looping through time and intersecting our moment again and again? In that picture, the direction of travel through time matters. Moving forward, the particle appears as an electron. Moving backward, it appears as a positron. As strange as this sounds, the mathematics allows it. Even today, quantum field theory often treats positrons as electrons going backward in time when doing calculations. As a literal description of reality, though, the idea doesn't hold. Not because it's obviously wrong, but because there's no way to test it. Whether electrons are many distinct particles or a single one tracing a complicated path through time makes no observable difference. Physics can't tell the two apart. It has no way to grab onto the distinction. So the one-electron universe survives as a curiosity. It reminds us that identical behavior doesn't require identical identity, and that sometimes two very different stories can describe the same physical world. That turns out not to be just a problem for particles. A similar limitation shows up when we turn to consciousness. Neuroscience has made one thing very clear. Consciousness isn't a substance hiding somewhere in the brain. It's a process. When matter is organized in a very specific way, neurons firing, networks interacting, experience appears. When that process stops, experience disappears. Under anesthesia, in deep sleep, or in brain death, there is simply no subjective experience taking place. What's easy to miss is that unconsciousness itself isn't something you experience. From the inside, it has no length and no texture. There's no sensation of time passing. No awareness of absence. There is just nothing at all. Now imagine a conscious process coming to an end. The structure that sustained it breaks down, and experience stops. Then, at some other time and place in the universe, matter happens to organize itself again in a way that produces consciousness. From the outside, physics treats these as completely separate events. They involve different atoms, different histories, different locations. But from the inside, there is no memory of the gap between them, no sense that time has passed, no experience of not existing. Subjectively, the next experience would feel immediate. That's where the question becomes unavoidable. If consciousness depends entirely on physical structure, and if identical structures generate identical experiences, then in what sense are these experiences different subjects at all? Physics has no answer to that question because it isn't built to ask it. Physics tracks matter, energy, causation, and time. It doesn't track perspective. There is no variable in our equations for this particular point of view. Once again, we reach a familiar wall. Two interpretations remain possible. One says that every conscious system creates a new, separate subject. The other says there is a single underlying consciousness that appears wherever the right physical structure exists. And just like the one-electron universe, there is no experiment that could ever distinguish between them. They predict exactly the same observations. This isn't a failure of neuroscience, and it isn't a gap waiting to be filled by a better theory. It's a boundary of science itself. Science works from the third-person perspective, while consciousness only exists in the first. We can measure brain activity and correlate it with reports. We can predict behavior with increasing accuracy, but we can never step outside experience to compare experiencers. So, a one-consciousness interpretation ends up in the same category as the one-electron universe. It's logically consistent, compatible with everything we know about physics, and permanently beyond experimental proof. That doesn't make it true, and it doesn't make it false. It places it outside the domain where physics can reach. Physics can describe the structure of the universe in extraordinary detail, but it cannot explain why existence feels like something rather than nothing. And that leaves us in an interesting place. We understand how patterns form, how matter behaves, and how consciousness depends on physical structure. But when we ask who is experiencing, whether identity persists, restarts, or is shared, we step beyond measurement and into something else entirely.